Hello, everyone. I am a teacher from Jiangxi Environmental Engineering Vocational College, Diao Xin Xing. Today we will talk about Water Pollution Control Technology course, Biological Treatment Technology part. Typical process of biological nitrogen removal. First of all, we can see the traditional three-stage nitrogen removal process. As shown in the figure, it is divided into 3 stages. They are organic matter removal, nitrification and denitrification. In the first stage, sewage enters the biological treatment system. Here, such an aeration tank can be used to remove organic matter. Then the sewage will enter the second biochemical tank. Nitrification will take place in this biochemical pool. Ammonia nitrogen in sewage can be converted into nitrate nitrogen. At the same time, there will also be a sedimentation tank for sludge backflow. Then the sewage enters the third biochemical tank. Denitrification can take place in this pool. Nitrate produced in the front pond can be changed, reduced to nitrogen, so as to completely remove the nitrogen in the sewage. So this is a traditional 3-stage denitrification process. It is based on the basic principle of nitrogen removal, and processes are designed, but it also has some problems. The first is to build a lot. The second one can be seen in the third pool. We have to add carbon source to it, so this is some of the problems it has. Second, we can see an improved 2-stage denitrification process. The 2-stage denitrification process is 2. The organic removal portion and the nitrification portion are combined. Then after merging the first 2 pools, remove the sedimentation tank in the middle. This is mainly because we found through research that bacteria that remove organic matter and nitrifying bacteria can coexist, so you can merge the 2 pools. It can happen in this biochemical time, removal and nitrification of organic matter. After the first biochemical pool reaction, then enter the second biochemical tank. Denitrification in the second biochemical tank. We can see that denitrification at this stage, it is still necessary to add carbon source to it, thereby realizing nitrogen removal. This is the 2-stage denitrification process. Next, let's see the AO process. The AO process is, the wastewater will first enter an anoxic tank, then there is the aerobic tank, followed by the secondary sedimentation tank. Through its construction order, we can see that it only needs 2 biochemical pools, and compared with the traditional 2-stage nitrogen removal process, the sequence of its biochemical pools is different. It begins with hypoxia. Nitrate reduction will occur in the anoxic tank, that is, denitrification process. In the second aerobic tank, nitrification will take place here, so we can see that nitrification and denitrification in this process, it's in reverse order, so that means that the nitrate produced in the second pool must find a way, return it to the first anoxic tank. The denitrification process can be successfully completed, so there is an internal reflux in this process. Effect of internal reflux. That is, the nitrate produced in the aerobic tank is refluxed to the anoxic pool in front, so as to ensure that enough nitrate is carried out in the anoxic tank. Denitrification. Eventually it will enter the secondary sedimentation tank. Nitrogen in sewage can. Better removal is obtained. Then as shown in the figure, this is BOD and nitrogen in AO process. Characteristic graph of bioconversion rate. You can see the removal of organic matter in the picture is showing a downward trend. Then ammonia nitrogen drops first, and then slow down, and then descend again, while nitrate nitrogen first decreased, and then go up again. Mainly, let's look at nitrate nitrogen. Nitrate nitrogen decreased in anoxic pool. This is due to denitrification in the anoxic tank, reducing nitrate nitrogen to nitrogen. Nitration reaction occurred again in the aerobic tank. Ammonia nitrogen in sewage is converted into nitrate in large quantities. So in the aerobic tank, nitrate, that is, nitrate nitrogen, will rise. Next, let's look at Bartonfo process. This process is first of all wastewater. Enter the anoxic tank and aerobic tank. Then there are anoxic tank, aerobic tank and secondary sedimentation tank. What is the difference between this process and the previous process? The main difference with the traditional AO denitrification process is that, after the second pool, an anoxic tank and an aerobic tank were added. To do so, what is its purpose? we can see that the ordinary OW process, it has been treated by anoxic and aerobic pond, then the nitrate produced by the aerobic tank. Most of them will pass. The internal return line returns to the anoxic tank, in the absence of oxygen, denitrified, reduced to nitrogen, but there is still a small amount of nitrate. Without internal reflux, it flows directly into the secondary sedimentation tank at the back. Eventually, it will follow the water inflow into the receiving water body, so the Bardenfo process takes into account this small fraction of nitrate. Is there any way to remove it? Mainly in the back, plus an anoxic tank. This anoxic pool can treat that small part of nitrate, continue denitrification, reduce it to nitrogen. Then there is an aerobic tank immediately after it. Some remaining carbon sources are further removed. Finally, it passes through the secondary sedimentation tank and then discharges water. So the Bardenfo process, it is an improvement on the basis of traditional OW process. Its nitrogen removal effect, generally speaking, it will be better than the traditional OW process. So let's finally look at one more. This is from Germany, Linpor process. So the Linpor process, we can see that it first enters a primary sedimentation tank. There will be an anoxic tank after the primary sedimentation tank, namely denitrification. Then there is an aerobic tank, nitrification pond. It can be seen that it and the traditional OW denitrification process, more similar. If you don't look carefully, can't see the difference between them. So what's the main difference? The Linpor process is primarily used in, many fillers are added to the aerobic biochemical tank. This filler is generally a filler carrier similar to sponge. This sponge filler can be suspended in water, let microorganisms attach to the packing. Its function has several aspects. The first is to make microorganisms. The sludge age can be prolonged. Therefore, it is beneficial to the growth of nitrifying bacteria. Therefore, the aerobic tank in Linpor process, nitrification will be stronger. Through this role, you can put the whole process. The nitrogen removal effect can be improved by one step because of the presence of fillers. In order to prevent packing overflow, so behind the aerobic tank, you usually need to add a grill, prevent the loss of filler. Alright, that's all for this class. Thank you all.